Dear viewers from all over the map, welcome to my channel. The Curious Tube features book reviews, tech tips, ways to earn money online, and more. In this video, I will walk you through the premise of alien civilization's existence and the possible encounter with alien life forms. Coming up next on the Curious Tube.
According to a new analysis from scientists at the University of Nottingham, we don't have a lot of alien company. On June 15th, two researchers published a paper in the Astrophysical Journal arguing that the Milky Way, which sports about 250 billion stars, could host as few as 36 alien societies. That's a small number, and rather less than the number of races that have appeared in Star Trek. The authors supplement their piddling tally with a second, more generous analysis in which they say that, okay, the count might be as many as 1,000. Either way, their conclusion is that, like Michelin star restaurants in Wyoming, extraterrestrial civilizations are few and far between. The implication is that our nearest cosmic chums are at least several thousand light years away. If so, finding them will be hard, and having a conversation will be impossible. So how did these British scientists arrive at such a depressing estimate? After all, there have been enough previous studies on this topic to fill a small hoard of hard drives. Some of these conclude that the Milky Way houses millions of societies. Others claim that, nope, Earth is special and alone. The Nottingham authors arrive at their low-ball estimate by using their own variant of the Drake equation, everyone's favorite method to gauge alien head counts. This equation, which can be found in the final chapters of nearly any astronomy textbook, is a concatenation of 7 parameters that, when multiplied together, yield the number of technologically adept societies in the galaxy. The parameters include the abundance of Earth-like planets, the fraction that spawn life, etc. However, it's the equation's last term that really rules the roost. It's the number of years that a technological civilization maintains its mojo. For how long does a society that's mastered physics and technology continue to beam radio or light waves into space? After all, if they stop doing so, we may never find them. In estimating the lifetime of a technological species, the Nottingham researchers make a big assumption. They note that we've been beaming signals into the ether for about a century. That's fair enough. But then they invoke what they call the astrobiological Copernican principle, and maintain that the universe is engaged in a massive Simon Says game. Whatever we on Earth have done, the rest of the universe also does, or has done. So because we've had radio for about a century, the Nottingham duo assume that all technological cultures will also use such technology for a century, but no longer. You might not have any problem with that. After all, we haven't yet found any aliens. So if we don't know something, such as how long they might stay on the air once they invent radar, radio, or television, it's tempting to take our own experience and apply it to everyone.
But that's like saying that, because we've had airplanes for a century, everyone will have airplanes for a century. And no longer. This is an astounding assumption. Radio can convey lots of information with a very low energy cost. It may be a technology any society would use for much longer than 100 years. Given the usefulness of radio, you could easily claim that the technological lifetime of societies is 10,000 years, not 100. If you argue for the larger number, the tally of inhabited worlds increases by a factor of 100. In other words, this arbitrary assumption by the authors is largely responsible for their strikingly low estimate of the number of alien societies. But wait, there's more. A second premise in the Nottingham paper is similarly astounding, namely, that every Earth-sized planet in the habitable zone of its solar system will spawn life, and after about 4-5 billion years, intelligent life. Now, of course, most scientists nod their heads if you state the obvious, that Earth-like worlds can spontaneously generate living organisms. Many would also concur that some will eventually evolve an intelligent species, but surely not all cousins of Earth are so blessed. That's like saying that every kid who takes piano lessons will inevitably win the Van Cliburn Prize. Each and every one. There's even a handy counterexample nearby. The habitable zone of our own solar system includes Earth, of course, but also Mars and, depending on your personal predilections, Venus. Neither Mars nor Venus is observed to have life, let alone technically competent life. The Nottingham paper has garnered a lot of attention because it says that the count of inhabited worlds is paltry, but don't be discouraged. You can make your own assumptions and derive just about any estimate you wish for the number of intelligent cosmic species. For myself, I figure that an absolute minimum would be 70, the number that managed to bag speaking roles in Star Trek.
Over the decades, scientists considering the possibility of life beyond Earth have pondered what such life might look like, how humans might be able to identify it from afar, and whether communication between the two worlds might be possible. That thinking has included developing classification systems ready to fill with aliens. One such system is called the Kardashev scale, after the Soviet astronomer who proposed it in 1964. And evaluates alien civilizations based on the energy they can harness. The Kardashev scale is a classification system for hypothetical extraterrestrial civilizations. The scale includes 3 categories based on how much energy a civilization is using. Kardashev describes Type I as a technological level close to the level presently attained on the Earth. Type 2 is a civilization capable of harnessing the energy radiated by its own star. And Type 3 is a civilization in possession of energy on the scale of its own galaxy. Each type also includes a numerical cutoff for the energy involved. But those weren't arbitrary cutoffs. He used things that are easy to visualize. Valentin Ivanov, an astronomer at the European Southern Observatory who has built on Kardashev's work, told Space.com, "I'm almost tempted to say it's a publicity stunt. These comparisons that he uses to make it easier for people to understand." Kardashev's scale is included in a 5-page paper published in 1964 and called Transmission of Information by Extraterrestrial Civilizations. Although the scale is what caught people's imaginations, Transmission of Information by Extraterrestrial Civilizations focuses on calculating how powerful a light signal from any point of the universe would need to be for radio scientists at the time to detect it. This value is also the numerical cutoff for the energy use of a Type 2 civilization. Nikolai Kardashev was a Soviet and Russian astrophysicist who died in 2019. Kardashev was roughly contemporary with early search for extraterrestrial intelligence leaders like Frank Drake, who published his famous equation 3 years before Kardashev's paper. Giuseppe Cacconi and Philip Morrison, who predicted what an extraterrestrial signal might look like. And Freeman Dyson, who pondered ways alien civilizations could surpass the limits of a planet. In addition to his scale, Kardashev developed a technique called Very Long Baseline Interferometry, which uses a global network of radio dishes as one radio telescope the size of Earth. Perhaps most famously, VLBI is used by the Event Horizon Telescope to observe black holes, including producing the first ever black hole image, published in 2019.
Kardashev also proposed supplementing Earth-based network VLBI observatories with space-based telescopes to increase its observing power even more. He advocated for the Russian mission Radio Astron, which launched in 2011, to do just this sort of work, according to a review of VLBI developments. If working only within the basic categories, humans are a Type I civilization on the Kardashev scale, literally speaking, because humans have not harnessed the equivalent of the entire energy of Earth. Other scientists have said that humans rank as more like a 0.7. Scientists and science fiction thinkers alike have referenced Kardashev's scale throughout the decades, and they have both praised and criticized the system. One benefit of Kardashev's scale is that it focuses on a civilization's detectability by humans, rather than its technological advancement writ large, much of which might come in ways that astronomers cannot observe. However, it has also been dubbed overly simplistic, both in considering only one characteristic and in its few, broad categories. The iconic astronomer Carl Sagan argued that Kardashev's categories represented too vast of leaps in energy consumption and proposed dividing each into smaller categories, Type 1.1, Type 1.2, etc. The Kardashev scale's focus on infinite growth as a measure of progress has also become difficult to swallow. It was rooted in the dominance of SETI at the time by radio astronomers. Ivanov said, "For radio astronomers, bigger is better," he said. Intuitively, for them, more power meant a more advanced civilization. Yet over the decades, as humans have begun to experience the global chaos caused by our tapping of fossil fuels, The risks of idealizing constant energy hunger have become clear. Kardashev's paper also speaks to the continuing core tension of the search for life beyond Earth. Is it more valuable to look for biosignatures, changes to a planet that only life at some scale from microbes to manatees can cause? Or for technosignatures, signals like radio waves that rely on not just life, but intelligent life skilled in noticeable technologies? There is an ongoing argument which of the two is more important, Ivanov said. But while Kardashev's work focuses exclusively on technosignatures, it acknowledges the biosignature side as well and suggests that each search can inform the other. The discovery of even the very simplest organisms, on Mars for instance, would greatly increase the probability that many Type II civilizations exist in the galaxy. He wrote, radio astronomical searches could of course play a decisive part in resolving this problem.
The Fermi Paradox. Where are the aliens? Nevertheless, the true heart of the paper that includes Kardashev's scale was a broader statement about SETI. It's often forgotten that what he did was to estimate the technical feasibility of interstellar communications. Ivanov said, the classification that he came up with is almost an afterthought of that paper, and in the paper's conclusion, Kardashev argues that even if the calculations don't hold up, the potential reality of interstellar communications should. We should like to note that the estimates arrived at here are unquestionably of no more than a tentative nature, Kardashev wrote, but all of them bear witness to the fact that, if terrestrial civilization is not a unique phenomenon in the entire universe, then the possibility of establishing contacts with other civilizations by means of present-day radio physics capabilities is entirely realistic. Looking back on the paper 50 years after its publication, one researcher wrote that Kardashev's scale was meant to represent a practical guideline for what could be expected in the course of SETI searches, not a profound theoretical insight into the nature of extraterrestrial intelligence. And even as scientists interrogate Kardashev's ideas, the scale remains an important facet of SETI work. Ivanov said his name will stay.
Thanks for watching. Give this video a thumbs up if you want to see more videos from this channel. If you knew of any useful information on this topic, let me know in the comments below. And if you're new here, click on the subscribe button and notifications icon for more useful information and tips from The Curious Tube.